Okay, so my topic for today is system design, scaling to 10,000 users. Just because I didn't get enough time to copy paste the diagram to 10,000 users. And why system design? Because I really like diagrams. Gives you a really clear picture about everything, right? So we can start over with the next diagram. So think of it our SSCRG website, right? When you open that, that's basically WordPress. But now you're gonna ask, well, who's hosting it? Well, it's the DNS provider, which is HostGator or other providers such as I forgot. Okay? And please, while I talk along the way, please correct me. Okay? So let's say you have your app. This is a Kindle, but let's say you have a mobile app or a laptop. You go hit Smart and Secure Computing Research Group.org. It does not go directly to the web server. It looks for the DNS, looks for the cache, and checks the corresponding IP address, which are the 127.0.0.0.1, which is localhost, but like those numbers. Now that gets sent back, again, IP address, and now once you have that, it goes to the web server to communicate. Correct me if I'm wrong. It's following the textbook. And that's for your single server setup. And now what we want to do is the scale, right? What if you have more users? First, there's two ways. One is vertical scaling, meaning you try to feed your computer a lot of memory until it cannot eat that memory anymore, meaning capacity is at maximum. It's like you have an iPhone, you can never buy a 1 terabyte storage space for an iPhone, right? You cannot extend that. So there's limitations. So come now we're to 100 users. With 100 users, you need to start thinking about storing your data as well. It's like customer info, retrieving data, database, right? So now you have another server, and it's called a database server. Again, in your database server, you store all of your data so that you can retrieve them, or you can store as well. And there's a lot of ways to use it. You can analyze, create dashboards, do machine learning, a lot of cool stuff. So now it basically just adds this. Now your web server would need to communicate to your database server, and then return that data, and then return to the user. Okay, so if you're following the MVC architecture, this is your model. This is your controller should be here, and you should be there. Okay. Next, we scaled now to 1,000 users. I talked about vertical scaling, right? But that does not work. So we now think about horizontal scaling. It's just basically adding another computer or server to, again, distribute the load. So in this example, there's two servers now, but how do you use them? How do you distribute? You now put a load balancer. So basically what this load balancer will do is you put it in front of your server in such a way that you can distribute the load. It's up to you. You can configure 50-50, round robin, 20%, 80%. You can configure it whatever you want. And again, this is just to show you how the DNS works. It just translates the string text to numbers, IP address. So that's for your 1,000 users. And interestingly, now you have 1,000 users as well. You have to be smart about your database as well. You have to think about replication, duplication, and creating this what we call master and slave. So basically, a master is where all your master copy is, like master shell in Blackboard. So all of your, think of it like your original data should be here, okay? And then now you want to copy, or what we call replicate, and these are what we call slaves. So why do we do that? First thing is, if all of the customers just interact with the master database, meaning you just write and read in one database, it's going to be so hard. It's going to be a lot of requests. I'll give you an example. For example, Amazon. There would be people searching, hitting the database. That's a lot of reads, right? However, there's also internal customer, meaning Amazon department, software developers of Amazon that needs to extract data as well. right? Or write data to it when they add a new product. So now both your Amazon employee and the users, meaning the customer, interacts with just one database. So why not separate them? Let's say I'm an Amazon employee, I input data, I only input in the master key. And then this now gets copied. And now because I have a million of customers, I can make them say, hey, don't read at this one because it might get too hot and need a lot of requests. Just go to my slaves and read the same data anyways.
What strategies does the system have for splitting up data between the databases, the slaves?
Actually, I don't know. Good question. I think I read about it somewhere before, but I don't have it on the top of my head.
I think there's several ways. I think I've seen one where you like do like a mod hash, and then depending on what the remainder is, you put it on like one database versus another by.
Yeah.
I'm sure think there's other ways.
There's a lot of strategy. Go
Where
ahead.
did you get this picture? You created what you copy. Yes. This one also our computing community. We are using that Python. Changing this one master is a primary, that is the secondary. Okay?
Primary, secondary?
Yes. We decided that, for example, Linux, when you learn the command is kill process. You only Peloton. Why
Kill?
don't you say delete the process, right? That's the why the term is not
Well, that's fun if you want FBI to look at you. You go Google search how to kill child process.
That's why our academia, we decided that using the right terms.
Okay. Also okay. So basically, you think it's more of like the industry
Primary and secondary. Yes.
convention that they use master and slave. So it's still 1,000 users. Now this shows you different ways. So this only means that when your master DB goes down, goes offline, there should be a slave database that will replicate the master, and this would act as master temporarily, so that all the writes would be redirected to this instead, until this goes up, or you create another master DB, or you promote. They call it promote a slave to master. So this shows again a good diagram that all the writes goes to master, and all the reads goes to a slave or other slaves. Okay, still the same. Next diagram. So now, what if a lot of users keep searching how to kill a child process, whatever, right? We don't want to keep them. We don't want to keep doing that. They request and it always reads from the database. Now we put a caching flow. Think of it when you're browsing your Facebook, right? It loads instantly. That's because it's already cached in your local machine, right? It loads some of the static assets, your HTML, CSS, and JavaScript right away. However, to make this efficient as well, you must think about some strategies like least recently used, like those kind of that, like first in, first out, time to live, meaning you don't want to store something that's like irrelevant to your user. Let's say you use Twitter, but you haven't used it in like 2 months already. You should like remove that in the cache right away, right? Because it doesn't make sense. And then another thing to talk about when we now scale to we're at 10,000 users. Okay, we are at 10,000 users. Is you create a content delivery network. Okay, and content delivery network, we basically what we do is think of the geography. If this origin comes from, let's say, China, it's too far away. So if a user interacts with, let's say, Alibaba directly, it would take 120 milliseconds, which would be long, right? So now use a CDN. Think of it as like a cache as well. But basically this one, you deploy it in the US, let's say. So that a person in the US trying to reach Alibaba would now load the static assets from the content delivery network. Okay? And you can strategize this as well, putting your CDNs in your ISP network providers. You can have them installed there if you're a big company. And how does the CDN work? Again, it works like a cache. You get image, if it's there, return the image. If you get image, it's not in the CDN or cache, right? It now goes to the server or where its origination.
So Netflix is using this model?
Yes. Netflix is using that model. That's why I say the ISP provider. they put it there. It saves money for Netflix and also for the ISP provider, because now they don't need to do a lot of pumps, right? So now we go next to showing you the whole structure. And this is also, I think, the last slide as well. So again, just to recap, what we did is the client first, we enter facebook.com, it goes to the DNS, now it checks, it translates to IP address, and now it goes to the load balancer first and checks which server is available, and now it checks if it's a write. If it's right, it goes to master. If it's a read, it goes to the slave. And now, if it's available first on the cache, turn out to the cache, and that's it. And second batch server tour is now.
I want to add one
Oh.
thing about cache. When the system uses cache, they tend to just check with the main server whether the resource updated or not. If it didn't update, they just use cache. If it still updates, they should go to the cache.
Yeah, so there should be a way that you can also make sure that the cache is like getting updated.
I think there is a HTTP request or something that checks whether the file is updated. When was the last time it updated? So that's the message for the
Yeah, that's very possible.
I'm ready.
Okay, thank you.